This is the final project Milestone 3 code video submission for the chessboard traversal group with Meg O'Brien, Logan Yoakum, and Katie Leapshire.
So for our final project, we're going to be comparing the speed and memory usage of different pathfinding algorithms with different numbers or different types of pieces, different numbers of max moves, and different ways of calculating the cost for a piece on the chessboard.
So for the inputs and outputs, we have quite a few things that the user has to implement and choose. So first of all, for our inputs, the user chooses the start location and end location for their chess piece, which piece they want, as well as the cost. And by cost, we mean, do you want us to calculate how many moves are made, or how many spaces are passed to get from one location to the next? The next thing the user has to choose is which algorithm that he or she wishes for us to use, how many moves we should calculate before we say that you've reached the max moves amount, as well as how full the board should be. For the outputs, we will have the time taken to find the path, the shortest path found, as well as the total cost, whether that's spaces or moves again. After we've completed this code, the goal will be to create a GUI which displays the chessboard as well as the pieces on the board and the piece that has been chosen by the user and the moves that are made, but that will be last step after creating functional code.
So in terms of major functions for our project, of course the major functions will include the pathfinding algorithms of Dijkstra's and A*, with the different backends for the priority queue, namely binary heap and Fibonacci heap. Then we'll have the make list function, which calculates the adjacency list from getting from the start location to the end location with the given piece and cost. And then finally, we'll have a fill board function where you give it a certain number of pieces to fill for white and black, and then it fills the board randomly with those specific pieces. Now, for the code that we have completed so far, we have the Fibonacci heap code written for the most part. We have the templated priority queue that'll be using our backends. And then we have most of Pathfinder written down, as well as a working makefile and main.cpp. Now, as you can see, main.cpp doesn't really have much code because most of it is abstracted to the Pathfinder class, and so we just have to simply call a few functions to do a lot of work. So now we'll show you an example of the makefile working.
So right now we have the makefile executable is actually already made. So first we'll do a make clean just to demonstrate that that works. And then we'll also do a make main to demonstrate makefile working. And now we'll show you the working code.
So right now what main's doing is it's going from the bottom left of the chessboard to the top right with a knight, and it's doing a max of 6 moves, which is the minimum you need to go that distance. So now it'll show us the adjacency matrix. And so as you can see, these are different options for each position on the chessboard as it completes its path. And so you can see for most of them, since it's the minimum number of moves, it only really has one choice. But then in one area, there's 2 possible ways it can go, and so it displays both.
So now that we have all this code still working, we have a few more steps to go to make this project as complete as we would like. So we need to implement a few more things within Pathfinder so that we can implement more pieces as well on the board, as well as different types of pieces. We need to complete fill board, i.e. what will fill the board with how many pieces we want. And then we need to connect everything together. So right now we need to make sure that priority queue and Fibonacci heap, as well as binary heap in the future, all work together properly. And then once we do that, then we will benchmark all of the different algorithms that we will complete. Dijkstra's is almost complete, and we will benchmark it so that we can see which backend and which algorithm are the most effective, as well as then that they are all consistent and give the correct outputs. Other than that, once we finish all of those, the ultimate goal will be to create the GUI. However, that will be the last step once we get all the algorithms correct.
All right, thank you very much.
Thank you.